To answer God, well, I just sat down and I felt like, okay, what can I do? Sitting down, sleeping, waking up, jumping around with the children, and the kids they don't even know what's up. They just want to do all manner of plays with you and all of that. I feel like, guys, I shouldn't be at home right now. You don't know. Okay. So I made one ventilator using some materials I have in my workshop, and I was able to have at least minimum of two controls: the breath per minute and the volume of air. That volume of air you can only control manually. The breath per minute using a pre-programmed controller. And for 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 an appreciation, what can I call it? A commendation. I got quite a number of attention. Uh, one of the national or international news station, took it over, and that made it got to the attention of so many people. Right now, I'm leading a team of 15 man engineer and medical practitioners to research and develop different equipment that we can use to combat COVID-19 at the Polytechnic Ibadan. And part of what we are looking at is a ventilator, a better version that can have all the necessary controls, feedback signals, and everything that we need to make sure that the ventilator is actually saving lives, rather than every random ventilator people have been producing that may not be in use. And like Joshua said, you can make it. It's in the power of those that are interested. I mean, the NGOs, the government, the the, the well-to-do people in the society to say, okay, let us scale this initiative. Let us support this person and make it go round so that it can actually work. I mean, so we needed the medical practitioners in our team so that we do not produce materials or equipment that would not be useful. So, I mean, we have this synergy whereby every step of the way they are checking what we are doing. Like I said, we have this automated hand washing, our hand washer that we're working on in bigger volume for the main gate, for rector service, and all of that. The plan is to, if the government or the any organization could provide fund, we could make this in large quantity and put it in different places in the society and not only in this institution. And because I work in a in a department that has so many of these emerging technologies under it as a course, the IoT, the automation, robotics, and that is what we call mechatronics engineering. So we are able to come up with quite a lot of things. We are doing some 3D printing as well. So we believe by next week we will be able to have a lot of products to deliver to the Nigerian society, other African countries if they want it. Like God suggested that we share knowledge, and depending on the initiative of the school management, we could make most of these things available. One good thing I made sure I established while developing most of these devices is that I'm working a lot on documentation. If you put a pin down, you must document that pin. Give me a documentation of what it does, of how to use it, and all of that. So, and everybody has been very okay with it because I believe in after 2 weeks of whatever we've been able to do, we should be able to have a manual, a document that we will present either to the school management or the government so that they can take it and use it to replicate whatever we have done. And even if they do they may if it is that they do not have the expertise, we'll be there to at least help but not just doing things. I was listening to someone saying that the era of patenting every idea is gone. That what we have right now is sharing ideas. If you do not share your idea, it might not scale. So open source make much more impact these days. So, and that's the way we should, I mean, that's the only way we can combat COVID-19. You don't say because there is pandemic and you have a particular solution and you want to hide it from others. No, we have
Okay.
to put our hands on deck and
Olukokun,
get the solution out.
let me interrupt you. Are you saying that for the project you are doing, the idea is when you finish design, you share the specifications so that anybody can duplicate it? Is that what you are saying? Bearing in mind that
Like I
we are
said,
working in an academic institution, which is different from IoT.
yeah, like I said we are having our own documentation
Okay.
to present to the school management, and because the school is, you know, a state government owned school,
Okay.
it may also be available to the state government, because this is to help combat COVID-19. Now, it's in the interest of the school to decide whether they want to make it open or not.
Okay.
But I would have loved it that for us to kick out COVID-19 quickly in our society, it be open source. Research will not end now, and we cannot make all the money now. So there are still a lot of solutions we need to put in place. And like Joshua said, tomorrow's problem, we have tomorrow's solution. We can only presume what may happen and try to work in that direction until we see the problem in its entirety before we can say this is the solution that really fits. You get
Okay.
it? So it's not all about profit. Right now, it's about the safety of every citizen. It's about, you know, returning back to our normal life and survival as it is right now.
Alora, I don't know whether you have observed that both of them, it seems that access to capital is a problem. Because, I mean,
Yeah, you know, I'm interested to. It's interesting to hear the both sides, because I think there was one guy or two who have also made a prototype for ventilators here
okay,
in Togo. I
okay,
haven't really followed his story, but I'll try and look for the link and share with you guys.
okay,
And you know, with our kind of organizations, they haven't really been open to receiving it. So I haven't followed the story, but I'm thinking it's the same kind of issue that they have, because one of them was saying material was an issue, finding, you know, local material that they could use to make the equipment, but also scaling up would be an issue in case, and we don't pray for this, but if there's upsurge in numbers for those needing the ventilator, then the country would definitely be in a difficult position. And we don't know if the local production can support it, and neither if there is any plans for importation of this equipment. So yeah, it's crazy.
it's like it's paining you.
You know,
Anyway,
but it could be good. It could be interesting if you can find local and international support. So I don't know what, like NGOs that we are working with, if they would be open to supporting this kind of initiative, or rather international organizations as well. keeping in mind that for now, things are going to change with the fund globally, seeing that the pandemic has really hit hard, and they would have to redirect the funds of many institutions towards dealing with this. So it could be a good opportunity to try and touch these international organizations.
Okay, I have a question for the two of you, talking about Joshua and Olukokun. We see in your presentation, both of you, one of the things that is clear is that there's no manufacturing base. So accessing raw materials is a problem. But here lies a case where the ventilators and other materials we are producing, I think, are going to be far cheaper. Because you produce a ventilator in your home workshop. How expensive is it going to be? I don't think it's in the tens of thousands of dollars. Is it?
Okay, no, not really. It was really cheap. I mean,
give us an idea.
Far less than, yeah, far less than $20. I mean,
$20. That is, what was the price of your Josh? There was something that you were that you did that was $20, right?
But you know, I mean, dollar has risen a little now, so I cannot say.
Look, we are not talking about naira. We're talking about dollars. Dollars is the value is the same everywhere in the world.
you
see,
no.
The point I'm trying to drive at is that
Nigeria.
Excuse me.
I'm saying Nigeria is special.
Okay. So I think Alora get the point, because now when I made those equipment, probably naira was around 360, 358, but now it's around 430 something naira per dollar. So do you get it? So
okay, because of the oil thing, I get it.
Because of everything itself. Now, the thing is, it's not about what we are producing. Like I said to all the interviewers and everything, what I produced was a proof of concept. It wasn't the real deal.
Like Joshua.
It was just
an IoT.
It was just that, okay, if this can save life, is this how it is? Can we have input of medical practitioners, people that can actually say, okay, do this, do that? When we have this kind of output, that is when you can save life. And that's what I'm getting right now with the Polytechnic Ibadan team. You get it? So what I made cannot be used to judge the price of a ventilator. And I shy away from calling it a ventilator, really. I call it an automated ambu bag or automated bag valve mask.
Chris, for those of us who are not engineers, calm down for us. Okay. For our sake, a ventilator is basically a device for helping people breathe, those who cannot breathe. For themselves. Definitely. And what Olukokun has done is same. It's a breathing device that he made with his own materials in his house, that you can press it manually to let it breathe. But he's now finding a way to use electricity to sort of let it breathe on itself. So it will be going up and pressing. I hope I've explained it in layman's terms.
Well, I don't know the kind of audience you are explaining that to, actually. But the back valve mask already exists.
Okay.
And is used for resuscitation purposes and to actually make people breathe, those that couldn't do it on their own. Okay. And it's manually done by nurses or doctors.
Oh, okay.
And that cannot sustain the COVID-19 people or victims or patients, because they stay on ventilator for a longer time, weeks sometimes. So for a nurse to stay there and be pressing that bag valve mask, so we are now automating it. Now, in automating it, in the automation, the NHS, National Health Service of the USA, now gave standards of how of of some controls that are vital
Okay.
to saving lives if we are to use this rapidly, they call it rapidly manufactured medical devices.
Okay.
Because of the situation in these advanced countries, that is why it was necessitated, because there was shortage of ventilators. The real mechanical ventilators, the high-end ones, have they have a lot of sensors, a lot of signaling systems, and they are very sophisticated and intelligent. They can individually regulate themselves through the input they get from the patient, and
Okay.
make sure that everything synchronizes. Now, these are there are three key controls that you must have if your ventilator will be useful at all. Number one is the breath per minute. You need to be able to simulate the breath per minute of individual patients. And that's why I was looking at the splitter that Joshua was showing to us, that
Okay.
you can divide the ventilator to 3 to 4 people. I wonder how you'll be able to make two patients to breathe at the same time and make sure the ventilator pushes the air to them at the same time. So
But I think he explained that that is more like a last ditch scenario where you're running out of ventilators, basically.
I mean, the usefulness will come in from the, when we have to re-engineer the ventilator in itself. If you have one outlet that is pushing air into a patient and is simulating the actual breathing of that person, right now as you are, probably you are breathing like 10 breaths per minute, and I'm doing 15 breaths per minute. I'm breathing faster than you are.
Okay.
And you want to split the same machine with me. So which algorithm will the machine run on? Is it your own, or will it average it for the two of us? I don't get it. So I believe the splitter will still be more of experimental than actual usage right
Okay.
now. So, but what I'm trying to explain is the breath per minute control is key, is vital, and it has to be individualized. And secondly, the what do we call it? The inspiration and expiration ratio, that is also key. Sometimes you may have one-to-one. I breathe in and I breathe out at the same time, or sometimes I breathe in deep and I breathe out at once. That's ratio 2-to-1. And sometimes I breathe in fast and breathe out slower.
Okay.
That's ratio 1-to-2. Inspiration, that is key to making that uh, device useful. I mean, if I didn't make the first attempt, I wouldn't know this as well. Then the third one is
So
the pressure volume control.
okay.
I mean, there is what we call it.
For the amount of
I
air that is
was
being
made,
pumped in the person's lung, the pressure
yes, I was made to
there.
understand that most of these rapidly manufactured equipment would do more harm to the patients than help them, because you have not measured the amount of air their lungs could take. And again, because the air is passing through tube, naturally with the law of pressure and all of that, the thing become more pressurized. So you need to control the pressure going into the lungs. You
Okay.
need to control the volume so that you don't cause barotrauma. So all of those things, these first three things are key. Then you can start talking about TEEP. I may not know the full meaning right now, and about 5 vital controls that uh, a ventilator must have if it has to be useful. And all of this, we are trying to take control in the new one we are doing, and we are using every means we could get it. So, and what we are trying to do is work from the known to the unknown. So after this attempt and the result we get, we'll be able to attempt the mechanical one. What we believe is the difference between what we are doing right now and what we'll be able to do is that we will not be using the ambu bag. We'll be using an air turbine. We'll be using different sensors, flow rate sensors, pressure sensors. The air will be well filtered. We'll have humidifier, and then we can now program a control unit that will be able to control this thing individually, take feedback from the patient, readjust itself, and let everything work like that. I believe with what I've said, Joshua understand me better than any of you guys.
Obviously.
And
but what I also get is that when you did your first prototype, you didn't know all these things. It was later on that the medical people came on board. They now pointed out these details to you that you don't have to factor into the design.
Yes.
Now,